Hello everyone, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as the concurrence regarding the quality of audio as well as video. If it has been bang on, write down bang on over the live chat, and then we are going to go ahead with the agenda behind today's and the sequence of the videos which are supposed to come. We have already discussed in yesterday's class that from yesterday onwards we had started a series on engineering mathematics which would be catering the demand of all of the branches, which includes electronics, electrical, mechanical, civil, chemical, production engineering. Almost all important topics we are going to cover within this series. As the videos are supposed to come in Gate Academy Global, my mode of communication is going to be English, and daily basis at 7:30 p.m. we are going to meet, and probably the individual videos would last approximately 1 hour. That means in daily basis we are going to spend the time in between 7:30 to 8:30. If you guys must have attended my last class, in last class I was discussing about the basic fundamental behind the permutation and combination. The formulas which we had listed down in the last class, probably you would be able to recall. What were those? If we had been talking about NCR, what does that mean by the NCR way? How many ways the R items can be selected, collected, or withdrawn out of n number of items without having order in our mind. And the outcome which we had derived is being R factorial. Just a minute. At numerator, it is going to be n factorial divided by of R factorial, n minus of R factorial. Yes. Similarly, we had also been discussed about the permutation. What does it mean by the permutation? Symbolically, permutation is being written as a NPR, and the NPR indicates how many ways the R items could have been selected out of n number of items. There, the order do also make sense. What was the formula? Basically, NPR was R factorial times of NCR. Why? Because if selection had been done of the R items, even the R items can be reshuffled and they can make different options. So that is why the R factorial is going to get multiplied over here. And here the result which we had been getting, it's been n factorial n minus of R factorial. Keep in mind, here we had just been doing the selection without ordering in our mind, and here selection with order. Selection with order. Yes. Let me focus over the agenda behind today's video. In today's video, we are going to take around 13 to 14 number of numericals based on the concept of permutation and combination. And keep in mind, the permutation and combination, as far as the topic is being concerned, has been very important for engineering mathematics, because the problem do come from this particular topic, specifically in the chapter of probability, and it's been very important for aptitude as well. So I would like to ask from each one of you, all of us are being ready for solving the problem onwards. If you guys are been ready, just write ready over the live chat, and then I am going to show you the first question. When I will show you the first question, approximately 2 minutes I would be giving to solve that problem. So you had to put your answer over the live chat, and then I would go into the detailed study of each and individual questions. So tell me, you guys are been ready or what? चलो फटाफट बताएंगे, you guys are been ready or what? Okay, all of us are been ready. So let me show you the first question. So here comes the first question from the permutation. From a group of 7 men and 6 women, 5 persons are to be selected to form a committee so that at least 3 men are there on the committee. In how many ways can it be done? So your timer starts now. For each question, I am going to allocate approximately 2 minutes. So within 2 minutes, you have to smash this problem out. Tell me what would be the best most answer. Read the problem carefully and tell me what could have been the best most answer for this given question. I would request to each one of you have the calculator whenever you attend my session. Let's see what the problem exactly says. The problem says we had got 7 number of men's. The number of men's are being 7. And similarly, we have got 6 number of women. 6 number of women. The 5 persons has to be selected for make a committee. That means the process which has been involved in this problem is just been selection. Nowhere the ordering do come into the picture. That means out of 7 number of men and out of 6 number of women, we are going to select the 5 number of members with certain predefined is in there. So obviously here we had been just talking about the selection. Nowhere the ordering had come into the picture. That is been very clear that in future we will try to crack this problem using the concept of combination. Is that part clear to all of us? Many of the students would also have doubts, sir, then how the problem related to the permutation would be framed. No doubt, after 2 to 3 number of questions, we had taken approximately 3 to 4 number of questions from the permutation as well. Do you have clear-cut idea why the combination only is being applied over this problem? Because here we are been selecting few number of men and women to form a committee. Nowhere the ordering had made sense. Agreed? Now, if you will focus over the next sentence, the committee has to be formed with the 5 number of members. So committee has to formed with 5 members. But along with 5 member, few more requirement is also being given, and it had been clearly given that the committee should have at least 3 number of men. What it indicates? That means the committee could have been formed with minimum 3, it's been said, no, minimum 3. 3 men out of 7 and remaining 2 has to come from 2 women out of 6. May I know whether this has been fulfilling your requirement or not? Obviously, sir. This, it had been clearly said that minimum 3 number of men is been required. We had taken 3 number of men, and just to make the committee members panel to be 5, definitely 2 has to be picked up from the stack of women which had been 6. Or you could have selected 4 men out of the pool of 7 and already 4 number of men is being selected, so only 1 woman is required to be selected from the pool of 6. Women out of 6 women, or all of 5 are being men. That means 5 men are being selected out of pool of 7, and no woman is being selected out of pool of 6 women. 6 women. Agreed? Anyways, I am not going to discuss much over here, but when we will be discussing about the probability, I would also be telling about the and becomes multiplication and or becomes addition. Or becomes addition. Mathematically, if we'll try to manipulate the above sentence, what is going to be that? See, out of 7 number of men, how many ways 3 men can be selected? Obviously, it is going to be 7C3, because here we had just been talking about the number of collection, number of ways the 3 person could have been selected out of 7. Let's take the 7 number of people had been there: Rahul, Sohan, Mohan, Kirti, Ajad, or maybe Sohel. So out of 7, how many ways 3 people could have been selected? It could have been the starting 3-1, it could have been the last 3-1, it could be the intermediate 3-1. So how many ways it could have been done? Obviously, it's going to be 7C3. And here the n do come into the picture. So obviously the multiplication is supposed to come. Out of 6 number of women, the 2 women is to be selected. This had been the mathematical convergence of this statement. Here the or do come into the picture. So obviously the addition do come into the picture. Again, out of 7 number of men, the 4 men is to be selected. How many ways it had been done? It's been 7c4 and that means again the multiplication is supposed to be done. And out of 6 number of women, only 1 woman is to be selected. 1 woman is to be selected. Or again the or had come onto the picture. Out of 7 number of men, how many ways the 5 men could have been selected? And out of 6 number of women, how many ways no woman could have been selected? Obviously this value is going to be 1 because you are not going to select any of them. So obviously how many ways you could have done? Obviously it is simply going to be 1. It's simply going to be 1. So you had to multiply them together and you had to get the answer. May I know what had been the exact most answer which we had been getting for this question? So I would like to have the input from each one of you. What had been the exact most answer? What had been the exact most answer? That is what I am saying. Have the calculator in front of you. So the calculation would be bit faster and you will also get confidence while solving the problem. So here it had been 7c4 into 6c1. May you know what used to be 6c1? 6c1 is been simply 6, which we have already seen. Na? 6c0 is been simply 1. So 7c4 is going to get multiplied with 6 plus of 7c5 into of 1. So the data is been 756. How many ways out of 7 men and 6 women, a committee panel of 5 members can be made where at least 3 men must be present? So obviously the answer is been 756. 756. So would like to ask from each one of you whether the concept related to this problem is been clear to all of us or something else to be taught once again. If it has been clear, just write clear somewhere and then we will move forward. Then we will move forward. Yes. Subham Anand 756. Gautam Das ready. Clear, no? Chalo. So in the same sequence, I think it's been the right time. We should also be taking the next question as well. And within 12 to 30 number of questions, you will be more than acquainted with any kind of the problem related to the permutation and combination. And once you're done with the permutation and combination related problem, we will use this concept into the concept of probability from where the question do come repeatedly. Yes. Okay then. In the same sequence, we had been moving into the next question as well. From a group of 7 men and 6 women, 5 persons are to be selected from a committee so that at least 2 women are there on the committee. In how many ways it can be done? So here we had been talking about the gender equality. So far we had the limitation in case of men that minimum 3 number of men to be selected out of the committee member of 5, but here there had been the bar of women as well. May I know what would be the answer? What would be the answer? I would expect the answer from each one of you because the same kind of the problem is just been solved before than this. So within 2 minutes, I want the answer from each one of you. Each one of you. Have the calculator in front of you, then only you will gain sort of confidence and you will be able to conquer any kind of the problem related to the probability. If you want, you can write the form of sentence and then you can convert that sentence into the mathematics, because at very initial exercise or practices, no, probably you will not be able to connect the word problem into the mathematics straight away. So you can take the help of sentence and then you can convert that sentence into the mathematics and you can get the answer thereafter. Tell me what would be the best most answer for this given question. Anyways, as far as this problem is been concerned, again we had been talking about the selection. Nowhere the order had come into the picture. Out of 7 number of men and 6 number of women, we had to finalize a committee which contains 5 number of members. Nowhere the order had come into the picture. So first thing should come in our mind whenever the problem had come in front of you, whether it's been the problem related to the permutation or combination. Definitely, sir, this problem is being based on the concept of combination where the order do not make any sense. That's been the first important point. That's been the first important point. Secondly, minimum 2 number of women are being required. So you can start like this. We had 2 number of women and 3 number of men, or 3 number of women and 2 number of men, or 4 number of women and 1 number of men, or all 5 committee member contains women and there had not been any participation from the men's side. It's been like this. Yes. Now only mathematics part has been left out. How many total number of women we had? Obviously the 6 number of women we had, and out of 6 we had to select the 2 number of women. How many ways we could have done this? This had been 6C2, this has been 6C3, this has been 6C4, 6C4, 6C3, 6C4, this could have been 6C5. And it had been clearly told whenever the and is being used over the sentence, the multiply is going to take place. Why it has been, we will be talking about that in great detail when we will be talking about the tree structure. Similarly, how many number of men's we had? The 7 number of men's we had. How many ways the 3 men's could have been selected? And that's been simply 7C3. Here goes 7C2, 7C2. Here comes 7C1, and here only one way this could have done. And as the or is being placed in between, obviously the addition is going to come over there. Yes. Anyways, I am not much worried about the exact value which we had been getting after deducing this complete expression. My basic fundamental is to understand whether the permutation and combination, which fundamental is to be used, and how to conquer any kind of the problem. So would like to ask from each one of you whether this concept has been clear to all of us, and then you can get it to your answer. There is no as such haphazard from here onwards. So from here onwards, you need not to have any kind of doubt at all, because many of the problems would have a different feature. Rather having 7 number of men's, they may have 7 number of red balls. Apart from 6 number of women, they may have 6 number of black balls, and they may convert the problem that they had to extract the 5 number of balls. How many ways they could have done this if the minimum 2 black balls are been there? So what had been there? Only and only items had been changed. Men had been replaced with red ball, women had been replaced with black ball. Rather forming a committee, we had been collecting 5 number of balls, and rather having least 2 women, we had least 2 black ball. And obviously the complete process is going to be same, and you will be getting the same answer. That is why rather calling it man, rather calling it woman, rather calling it black ball, rather than calling it red ball, we had just been talking about items. Out of 6 number of items, how many ways the 2 items could have been selected? That item could be ball, that item could be man, that item could be woman, that item could be orange, that item could be apples. Agreed? In the same sequence, I think it's been the right time we should also be focusing over the next question as well. Here comes the next question. In how many ways the different ways can the letter of the word leading be? That means in how many ways this letter, this word leading could have been rephrased. So your time starts now. Within 1 minute, you must be able to solve this problem out. As such, no ambiguity in this problem. Straight away, you can find this problem. In how many ways, how many different ways can the letters of word leading be? Tell me. In how many ways the different words can be phrased with the letters of leading? The answer had started coming. Subham is saying 7 factorial. Anyone else apart from Subham? 7 factorial is being said by Subhangi. Great. Anyone else apart from the 2 answers which we have received so far? As per the Subham, the answer has been 7 factorial. As per the Subhangi, the answer has been 7 factorial. Time is up. The best answer for this given question has been 7 factorial. 7 factorial. 7 factorial. Whenever you had this set of problem, no, few number of basic process has to be followed. First, count how many number of letters are been there. How many number of letters are been there? Obviously, it's been 1, 2, 3, 4, 5, 6, 7. So number of letters which contains by word leadings are been 7. Now, at the same time, you also had to see whether any repetition within the letter. No. Why we had been talking about the repetition? See, if two L's are been involved within the same word, if L is being swapped from its place, the new word which will be framed, no, that would be very same as the older word. Did you understand what I'm saying? What I'm saying, let's take it must have been leading. Instead, the leading it must have been Leadinl. And if the swapping between the last and first letter would take place, the word would remain same. There would not be the different varieties in word. So you also had to see whether there are been any repetition in letters. No, sir. As such, there are not been any repetition. So what had been happening? Put together, the 7 number of items are being selected. The total 7 number of items are being selected, collected. Items are being selected and they had been ordered as well. Why? Because if all of the 7 letters are being selected, they can be rephrased. The E may come first, then L may come. A may come first, then L may come. Put together what had been the basic chronology behind this problem. This has been a problem of permutation. Why? Because if you will rephrase the letters which are being associated this word, it is going to make the different words. So one thing has been quite sure, as far as this problem is being concerned, the order of the letters are going to make the different words. And as we had been talking about the different words which we can frame from the letters which had been used in the leading, obviously this problem is being based on the concept of permutation. How many of us are being agreeing on this point? Yes, sir. This has been a problem of permutation. Even rather having a word, it could have been a number as well. It could have been 1, 2, 3, 4, 5, 6. And there they could have asked, using this 7 digits, how many different numbers can be framed. There also there would be a problem of permutation, because if 1, 2 or 2, 3, if their places are being swapped or if their sequence is being changed, definitely you are going to frame the different number altogether. Agreed? No? Yes, sir. So this has been the problem of permutation. So total 7 numbers or items we had, and how many number of boxes we had? 7 number of boxes we had. It's been 1, 2, 3, 4, 5, 6 and 7. How many ways this 7 number of items could have been arranged within this? In first block, we had got the opportunity that all 7 items must have been filled. If one item has been filled in first box, obviously we had been left out with 6. If the second item or the number is also been fixed in second blocks, we had been left with 5. It goes 4, 3, 2, 1. Once we'll multiply all of them together, it is being simply equals to 7 into 6 into 5 into 4 into 3 into 2 into 1. And mathematically this could have been written as 7 factorial. 7 factorial. So from here onwards, just have one thing in your mind. If out of n number of items, if all n items is to be selected and has to be ordered, the value is simply going to be n factorial. In terms of permutation, it could have been written like Out of 7 number of items, all 7 items are to be selected and ordered. So obviously it is going to be 7p7. May I know what used to be the worth of 7p7? It is going to be n factorial, that is being 7 factorial, and towards denominator side it's going to be n minus of r factorial, that is being 0 factorial, and put together the result is being 7 factorial. Put together the result is being 7 factorial, and that had been coming somewhere. How much it had been? 504 or what? 7p7 or 7 factorial we can write. 7p7 5040. This many ways the different words could be rephrased. Different words could be rephrased. Would like to have the input from each one of you. Did you really understood what had been the basic crux behind this problem? And if the answer is been yes, just write yes over the live chat, and then we will move into the next question as well. So either you can use the concept of permutation, or straight away, whenever you had this sort of problem where you had been stuck with a number or maybe a word where just by swapping their digits or just by swapping their letters we had to find a different number or different word, what you had to do, you had to just count how many number of digits, how many number of alphabets are been involved, just apply the factorial behind that. So that is why in the two different ways the same problem is being solved. First in the method of manual understanding, and the second is being the concept of permutation. In the same sequence, I think it's been the right time we should also be taking the fourth question as well. In how many different ways can the letter of words leading be arranged in such a way that the vowel always comes together? Again, they had been talking about the different ways this alphabets can be arranged and would result the different words. That means not only collection, even their order do also make sense. This had been a problem of permutation once again. So within 1 minute, you guys had to solve this problem, and your timer starts now. Tell me what would be the best most answer for this given question. As per the Subham, the answer has been 5 factorial. Anyone else apart from Subham? Time is up. Let me reread this problem once again. The problem states, in how many different ways the letters of word leading be arranged in such a way that the vowel always comes together. Anyways, as we had been dealing with the letters of the word, and the arrangement of the letter of the words would frame the different words. That means here collection as well as the ordering both had been coming into the picture. That means this problem is being the problem of permutation. You had to first fix it down whether you had to deal with the permutation concept or the combination concept, then your life would become much easy. That's been the first thing. Here they were talking about vowel somewhere. May I know how many number of vowels we had in English alphabet? 5. And they are been A, E, I, O, U. In this problem, they had given foundation. Whenever the leading alphabets are being shuffled, all of 3 vowels which are being included within this alphabet has to come together. May I know where they have been? So obviously E is been 1 vowel, A is been 1 vowel, and I is been 1 vowel. 1 vowel. Agreed? Let me go forward. So what we had done, all of 3 vowels together had been counted as 1 alphabet. So how many number of alphabet we had? We had 1, then 2, then 3, then 4. So we had 4 alphabet, and as it had been clearly said that all the time the 3 vowels should come together. So we had taken the 3 vowels packet as a single packet. So obviously they would be counted as one alphabet. Alphabet. So total how many alphabets we had been left with? Obviously, sir, we had just been left with 5 alphabets. 5 alphabets. How many number of blocks we had? 5 items we had. 5 items we had, and 5 number of blocks we had. 5 number of blocks we had. 1, then 2, then 3, then 4, and then 5. Why I'm calling it 5 block? Because in either of the block, either you take first, second, third, or fourth, the 3 number of vowels has to go together. Either it could be in first block, it could be in second block, it could be in third, fourth, or fifth block. Put together, the number of alphabet still remains 1, 2, 3, 4, 5, 6, 7. 3, 3, and 7. Yeah. May I know how many ways it could have done? Obviously, it could have been done with a 5p5, which is been straight away equals to a 5 factorial, which we have already seen. If out of 5 number of alphabets, if you wants to know how many different words we can phrase, so obviously that is simply been 5 factorial. This has been simply been 5 factorial. 5 factorial. Yes, but still there had been a important point, my dear friend. But vowel which had come together, no, which contains A and then E and then I, EAI. When they would reshuffle their place, still the new words are going to phrase. What I'm saying, if EIA together had been in a place of first block, keep in mind there had not been any change in second, the third, fourth, and fifth block. But if there had been the reshuffling between EIA, still there would be the formation of new words. And so far we had not been taken the consideration of the shuffling of vowel as well. We had just been talking about the shuffling between this 5 number of blocks where the vowel together is being taken as one block. So how many ways this EIA can be shuffled and can be made the different three alphabet long words? That is being 3 factorial. Do you have the clear cut idea about it? Do you have the clear cut idea about it? So end of the day, how many different words we can make when the alphabet is being taken as packet? Obviously it's been 5 factorial, but whereas the vowels can also get swapped and can make the different words put together, the result which we are going to get, it's been 5 factorial and 3 factorial. May I know how many of us had made the mistake over here? So here it becomes and the result has been 720. The result has been 720. So the answer which we had got so far has been from Sumangi Gupta. The answer has been 5 factorial. From Subham Anand, the answer has been 5 factorial. Both answers are been wrong. Both answers are been wrong. So would like to ask from each one of you, the concept behind this problem had been clear to all of us, or yet few doubts are been left out. If few doubts are been left out, definitely I would repeat the concept once again. What had been the crux behind this problem? So far in last problem, they were talking about how many different words can be phrased using the word leading by shuffling their alphabets. What had been their worth? That had simply been 7 factorial because there had not been any repetition between the alphabet. But here they had given an additional foundation that all of the vowels should come together. If all of the vowels should come together, E, A, and I had made a single packet. Yes, sir. They had made a single packet. So may you know how many number of blocks we had, my dear friend? L, A, and I together had made a one block. Yes, that had been they had been taken as a one alphabet, and remaining alphabets are being 4. So put together we had got a 5 number of blocks. The 5 alphabets, how many ways it can be fed within a 5 different blocks? It's been 5 factorial. But most of the student had not gone into this detail that the vowel which we had selected can also swap their places and they would be making the 3 factorial different ways, and put together the result is been yes 5 factorial and into of 3 factorial. Yes, no? Okay then. It's been the right time. We should also be focusing over the next question. So here comes the next question. In how many ways, how many different ways can the letters of the word corporation can be arranged? Corporation can be arranged. And your time starts now. Read the problem carefully and tell me what could have been the best most answer for this given question. Your time starts now. Read the problem carefully and tell me what could have been the best most answer. First, focus whether the permutation or the combination is to be used, and then by using that concept, get the answer. Subham Anand 11 factorial divided by 2 factorial and 2 of 3 factorial. Probably it's been a correct answer. See, whenever you have this sort of problem, no, you can have this alternate. Rather using permutation. One thing has been quite sure, the problem is been based on the concept of permutation. Because here the ordering of letter do also make the different words. It's been a problem of permutation. May know how many number of alphabets are been involved. How many number of alphabets or letters are been involved. They are been 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 number of alphabets are been involved. So far we did not have any repetition within the alphabets, but in this problem we had the repetition. C, it has not been repeated. O has been repeated thrice. So as far as the O as alphabet is been concerned, it's been repeated thrice. It's been repeated thrice. Similarly, R. R is been repeated twice. R is been repeated twice. R is been repeated twice. Then P has not been repeated. O is already been taken. R is already been taken. A has not been repeated. T has not been repeated. I has not been repeated. O and N has not been repeated. Has not been repeated. So in this sort of problem, what you have to do? First of all, out of 11 number of alphabets, all 11 alphabets are to be chosen and then has to be ordered. Put together, it's simply gonna be 11P11. 11P11, which stands for 11 factorial. 11 factorial. But you can see very well, if there had been swapping between these O's, there would not be any formation of new word. And as far as the 11 factorial is being concerned, it had been presumed that whenever the swapping between the O's would take place, it would also create a new word, which is not true. Did you understand what had been the loophole behind this problem? As far as the 11 factorial is being concerned, the 11 factorial states out of 11 number of items, how many ways their selection and ordering can be done. That means out all 11 number of items are being selected and they had been ordered. So according to 11 factor, even the O is being swapped, no, that has also been counted within 11 factorial. Even this O's are being swapped, that is also being counted under 11 factorial. Not only that, even this R which has been swapped is being also counted under the 11 factorial. Although when the R and R is being swapped, they are not going to form any word. If O's are being swapped in the same place, they are not going to form any word. So what we had to do, those values which are being associated within the 11 factorial has to be brought out. How do we do so? Oh, how many times it had been repeated? 3 times. So obviously 3 factorial is going to get divided, and similarly 2 factorial. From where this concept had come? 11 factorial had come from the concept of 11P11. How many ways the 11 items out of 11 items can be selected and can be ordered? Obviously it's going to be 11P11. How many ways 3 items can be selected and can be ordered? So it's going to be 3P3, which stands for how many ways the different ordering of the O which had been already included within the 11 factorial into of 2P2. 2P2. So end of the day, the result in this problem is going to be 11 factorial, 3 factorial, into of 2 factorial, into of 2 factorial. Yes. So this has been the answer for this given question. So let me take another question. Let me take one name. Yes. Subham. We had taken another word. Subham. I would like to ask from each one of you, how many different or distinct ways this words can be written? How many distinct ways this word can be written? Read the problem carefully and tell me what could have been the best most answer. And your time starts now. And your time starts now. The same concept is going to be used here as well. Here as well. First, you have to count how many number of letters are been involved. That they are been 1, 2, 3, 4, 5, 6, 7. Numerator is going to be 7 factorial. And out of 7 number of alphabets, few alphabets are been repeated. S, no repetition, sir. H, yes, 2 times it's been repeated. U has not been repeated. B has not been repeated. A has not been repeated. M has not been repeated. So how many ways the different words could have been phrased by the word Subham is being 7 factorial divided by of 2 factorial. 7 factorial divided by of 2 factorial. Agreed? Let me take another question. Let's take another word, elephant. Elephant. Now would like to ask how many different ways by using the letters which are being used within the elephant the distinct word can be made. What does that mean by the distinct word? If E and E is being in same place, no, definitely it is making the same word. I won't count those word as a different word. As different word. So again, what you have to do, you have to focus over the number of alphabet that the word carries. That's been 1, 2, 3, 4, 5, 6, 7, 8. So numerator is gonna be 8p, 8, and that is been 8 factorial. And let me focus over the alphabet of the letters which are been repeated within the words. E. Yes, it had been repeated, sir. How many times it had been repeated? Only and only 2 times. So it's gonna be 2 factorial. L has not been repeated. E already been counted. P has not been repeated. H is not been repeated. A is not been repeated. N is not been repeated. And T has not been repeated. So obviously, how many ways the different words could have been phrased? It had been 8 factorial divided by 2 factorial. 8 factorial divided by 2 factorial. Let me take another question. Rather taking elephant, I have taken elephanta. Deliberately, A has been introduced at the last of this word so that we will have a better variety. Now, rather having 8 number of alphabets, we had the 9 number of alphabets, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the numerator is going to be 9p9, that is stands for 9 factorial. And towards denominator side, what had been happening, E has been repeated twice, so it's going to be 2 factorial. And similarly, now the A has been repeated twice, it's going to be into of 2 factorial, into of 2 factorial. So I would request to each one of you, don't even try to mug up any of the concept. Just go ahead with the basic concepts of combination and permutation and try to connect this concept with the concept of permutation and combination. You will be more than understanding the concepts. Have you written this? Then we will be moving into the next. If all of us had write this, obviously you had to write it clear. You have to write it clear, and then we will move forward. And then we will move forward. And as far as the agenda behind the live videos which we are going to take, I am going to cover probability completely, which starts from permutation, combination, word problem, probability distribution and density, stats. Each and individual problem, each and individual concepts would be taught in great detail, and probably it may last even 30 to 40 days as well. So you can expect none means none of the questions from the probability would be left from you guys if you are been attending this complete classes. And if the strength of the population is being maintained in life, probably I may also finish the complete engineering mathematics as well. Now here comes the next question. In how many different ways can the letters of word corporation be arranged so that the vowel always comes together? Vowel always comes together. So the concept which we had studied so far, we had to reintroduce those concepts in this problem, and definitely you will be able to conquer this problem well. Tell me what would be the best most answer over here. So let me start the timer once again, and timer starts now. And this has been my Telegram. So I would request to each one of you, try to link this Telegram with me. So definitely in future, any kind of suggestion, any kind of doubts you guys may have, I will try to spare my time. I'm not sure about it, but still I will try to spare my time. Tell me. In how many different ways can the letter of the word corporation be arranged so that the vowel always comes together? Time is up. First thing, whenever you had been playing with number or word, so there not only selection is being concerned, even the ordering is also makes sense. So it is been ordering along with selection, it's been a problem of permutation. Permutation. Next important point. How many number of letters are been involved with the word corporation? How many letters? How many letters? They are been 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters are been involved. 11 letters are been involved. How many number of vowels are been involved with this word? Vowels. O is been the first vowel, and then the another O is been the second vowel, then A is been the another vowel, I is been the another vowel, and another vowel is been O again. How many number of vowels we had? 1, 2, 3, 4, 5. 5 number of vowels we had. And as it had been clearly given that all 5 vowels has to go here and there together. That means they will make a single bunch. So what had been happening? So what I am saying, this 11 number of letters, no, out of 11 number of letters, 5 number of letters together will move here and there. So how many number of blocks we had been left with? See, 11. If 5 is been subtracted, 1 is been added, total 7 number of blocks we had. How could I know about it? See, out of 11 number of letters, 5 letters are being subtracted, and actually this 5 letters together is being a packet of a single alphabet. So here it had been 11 minus of 5, that's been 6, plus of 1, and that had been 7. That had been 7. Yes, we will move forward. So again the same thing. How many ways the 7 object can be selected and ordered out of 7 number of items, and that is been 7p7. 7p7. Yes. Or straight away we could have written this as 7 factorial. But did you see or not? Apart from O, O, A, I, O, have you had any repetition? Yes. C has not been repeated so far. The R has been repeated twice. P has not been repeated so far. T has not been repeated so far. N has not been repeated so far. So even when we will be talking about how many ways the 7 items could have been selected and ordered out of 7 number of items, it would be 7 factorial divided by f2 factorial, because which one? R has been repeated twice. R has been repeated twice. Have you idea about it? Yes, sir. But still you had to have one idea that the vowels which we had brought out, 5 number of vowels, what were those? They were O, O, and then we had A, I, O, A, I, O. Even when they will swap their places, they are going to make a different word within the pack of 11 number of alphabets. May I know how many ways or how many different ways they can be rearranged? How many number of alphabets we had? 5 alphabets. So obviously it is going to be 5 factorial. But you can see very well the O is been repeated thrice. So here at denominator side, we are going to have 5 factorial divided by 3 factorial. So end of the day, if we'll talk about the number of different ways by using the alphabet of corporation, the different words can be rephrased or can be framed, that is being simply equals to of 7 factorial divided by of 2 factorial. So far the vowels is being taken as single block, but by shuffling their places, they are going to make the different words. How many ways? It is simply going to be 5 factorial divided by of 3 factorial. 5 factorial divided by 3 factorial. May I know what would be the answer over here? So 7 factorial, 5 factorial. That answer has to be calculated by you guys. Tell me how much answer we had been getting. So here it is going to be 7 factorial into 5 factorial, and towards denominator side it's gonna be 2, and it's gonna be 2 into 3, 2 into 2 into 3. So here it is going to be 7 P7 into 5P5, 5P5 divided by 12. So 50,400 different ways the words could have been phrased by the word corporation. By the word corporation. Would like to ask from each one of you whether the concept behind this problem has been clear or not. Because from the first question onwards, I had raised my level a bit. The first question was the easiest most question. Second, third, fourth, slightly and sluggishly, I had been improving the quality of question. And you can see very well the sixth was a well-crafted question where the corporation, a word is being used using all of the letters of the corporation. I just wanted to know how many different ways the different words could have been rephrased. And at the same time, one extra foundation is being supplied along with this problem, that the vowels are or have to come together. So what I did, first we have calculated how many number of alphabets are being associated with the word corporation. It's been 11. How many number of vowels are being associated? It's been 5. What we did, we made a block of 5 vowels as a single block. So how many total blocks we are going to have? 11 minus of 5 plus of 1, and that is been 7 blocks. In 7 blocks, how many different ways the 7 items can be fed with its order? It is been simply 7 factorial. But this is also to be noted that the R is been repeated twice. So definitely in 7 factorial, the swapping of the R must have been taken as the different words all together. They are not been different words. If the R is been here and R is been there, and if they have been reswapped or the swapped, still the word is been remain same. So obviously few deduction is to take place, and that is been 2 factorial. And now so far we had taken the packet of vowel as 1, but there also the swapping can take place, and when there the swapping would take place, they would lead a different word. So how many number of vowels we had? 5 factorial. But if the swapping between o would take place, definitely they would not be counted as a different word. So there would be the reduction of 3 factorial. Agreed now? How many ways they could have been arranged? Let me take an example. So it's been 5 factorial. 5 factorial is going to be 2 into 3 into 4 into 5, and it is going to be 2 into 3. So 20 ways it would have been done. 20 ways it could have been done. Agreed? Subhangi, I exactly could not understand what exactly the problem you had actually. So you can elaborate your problem once again. Would like to ask from each one of you, the concept behind this problem has been crystal clear to each of one. And if it has been clear, just write clear over the live chat, and then we will move ahead with the next question. So you yourself would be able to feel that at very beginning we had taken only and only simple phrase of problem, but over the period of questions we had been increasing our quality of question. Did you have a clear-cut idea? What was the basic crux behind this problem? Whenever you had a number which includes few number of digits, whenever you had word which includes few number of letters or few number of alphabets, and if we had been talking about phrasing the different numbers by using the given digits, or we had been talking about the phrasing the different words using that alphabet, the concept of permutation do come into the picture, because not only selection, even their order do also come into the picture. So far, whatever the word we were choosing, there were no repetition as far as their alphabets are being concerned. Like if you had the 5 distinct alphabet, how many ways they could have been selected, that is been simply 5 factorial. But as they had started being repeated, so what we have been doing, let's take alphabet is been repeated twice, so 2 factorial would be divided towards denominator side. Another alphabet is been repeated thrice, so 3 factorial is going to be divided towards denominator. Okay, 7 block, you did not understand what I'm saying. See, total 11 letters we had. 1 2 3 4 5 6 7 8. How many blocks we had? 1 2 3 4 5 6 7 8 9 10 11. 11 number of blocks we had. Why we had chosen 11 number of blocks? Because all of the alphabets which are being used within the corporation is to be used. How many alphabets are being there? Obviously 11. It had been clearly said that all of the vowels has to move together. How many number of vowels we had? The 5 number of vowels we had. So what we did, 1 2 3 4 5. This 5 number of blocks are being freezed, because whenever the vowel moves, they would move together. Here maybe they come here, they may come here. So what we did, we had freeze this 5 number of blocks, and we had presumed this 5 number of blocks as a single block. So how many number of blocks we had? 1 2 3 4 5 6, and this together is being 7. So whenever the movement do takes place, this can come here, this can come here, all together this can come here. So how many ways this suppling can be made? And that is being simply equals to of 7 factorial. But as there had been repetition in R as well, that is why the 2 factorial had come. So do you have a clear cut idea from where the 7 factorial is being come, and from where the concept of the 7 block had come? Gautam Das, did you find this explanation? Okay, then we will move forward. Then we will move forward. Okay, then in the same sequence, I think it's been the right time we should also be focusing over the next question as well. Out of 7 consonant and 4 vowels, how many words of 3 consonant and 2 vowels can be formed? It's been a very asan question, I would say. Tell me what would be the bestmost answer for this given question. Probably within 15 to 20 seconds, you must be able to crack this problem out. I could have taken this problem at very early stage itself, because it has been a very asan question as far as the level of the questions which we have already taken so far. I would request to each one of you, I want the answer from each one of you, exact answer in terms of digit. Out of 7 number of consonant and 4 number of vowels, how many words of 3 consonant and 2 vowels can be formed? So answers have started coming. From Ranjan, the answer has been 210. Anyone else apart from Ranjan? As per the problem, total 7 number of consonant we have. Consonants we have 7 number of. And how many number of vowels we had? 4 number of vowels we had. And as per the problem, how many words of 3 consonant and 2 vowels? That means the word which we are going to rephrase now, it would have alphabet length is equals to 5. Alphabet length is been 5. Alphabet length is 5. And even the prerequisites are being clearly given. how many words of 3 consonant? That means the word which we are going to phrase is going to be 5 alphabet long. By default, the 3 consonant must have been selected out of the bunch of 7, and similarly 2 vowels must have been selected out of the bunch of 4 vowels. So here this has been the case of 3 vowels to be selected out of 7 number of, sorry, 3 number of consonant to be selected from 7 number of consonant. Not even their selection, even their arrangement do also make sense. Why the arrangement do also make sense? Because they are in the different consonant, and once you select and the ordering would be changed, obviously they are going to frame the different words. And in case of and, obviously the multiplication do takes place. Out of 4 number of vowels, the 2 vowels are being selected and they had been arranged. They had been arranged. So it had been a straight problem of 7p3 into of 4p2. Let me see what had been the answer over here. So it's gonna be 7p3, sorry, into of 4p2. 4p2. So the answer which we are supposed to get, it's been 2520. 2520. So the answers which we had received so far has been 210, which is gonna be a wrong answer. How did you get 210, Ranjan? Have you used combination over there? Let me see over there. 7 C3 into 4 C2 C2. Yes, the permutation is going to take place. Ranjan, there had been a mistake which you had done. What I am saying, see, out of 7 number of consonant, if 3 consonants are being selected, but their arrangement do also make sense. Let's take you had selected R, you had selected T, and let's take you had selected K. This has been a one kind of selection, but even their order would also make the different word. RTK, KTR, maybe TKR. So the formation also had the impact of ordering. So this is just the problem of permutation, where the collection as well as the order both had made sense. Both had made sense. Each one of you had the clear-cut idea about this problem. If this problem is being clear, we will be moving forward. We will be moving forward. Tell me. Clear now? Okay then. Let me move forward taking the next question as well. Here comes the next question. Very simple question. Tell me what would be the best most answer. In how many ways can the letter of word leader can be arranged? Leader can be arranged. Again, it's been a problem of permutation because collection and ordering both are being involved over here. How many number of alphabets are being associated with this word? It's been 1, 2, 3, 4, 5, 6. So towards numerator side, it's going to be 6 factorial, or I can write this as a 6p6, which leads 6 factorial. Do you have any repetition over the alphabet? L has not been repeated, E has been repeated once, A has not been repeated, D is not been repeated, R is not been repeated. Simply it is going to be 2 factorial. 2 factorial. Whatever the answer we get, yes, that would be the answer. Random variables, definitely the random variables would be my part of big concern, because I can understand most of the students do not exactly feel from where the concept of the random variable had come into the picture. keep in mind, I would be focusing over the part of random variable into great detail. Probably the part of random variable and its distribution and density, we may spend around 25 to 30 hours. 25 hours minimum I'm going to spend in random variable and distribution and density, because I can understand this has been a very, very important topic for all of the branches. Either you have been mechanical, civil, electrical, electronics and instrumentation. We will spend good amount of time with random variable and random process. Okay, then in the same sequence, we will be moving forward, taking the next question as well. Problem says in a group of 6 boys and 4 girls, 4 children are to be selected. In how many different ways can they be selected such that at least one boy should be there? One boy should be there. Before solving this problem, I would like to ask a simple question whether this has been a problem related to the permutation or combination. Whether this has been a problem related to the permutation or combination. Obviously, this has been a problem related to the combination, because here only selection do make sense. There had not been any concept of ordering at all, because we had not been dealing with any number, we had not been dealing with any alphabet, we had not been making any number, we had not been making any word. So obviously this has been a pure problem of combination. In this problem, it had been clearly given in a group 6 number of boys we had. The count of boys are been 6, and similarly the count of girls are been 4. The 4 children are to be selected for any purpose. We had been making a group of 4 children, and within that 4 children, at least one boy should be there, the part of that group. So what could have been the different situation? I had taken a situation in the group, only one boy we had, and the remaining 3 girls, or we had 2 number of boys and the remaining children are being girl, or 3 number of boys we had and the remaining are being girls, or all of the 4 children which are being selected are being boy. Obviously we had not been left out any space, so no girl is being selected. No girl is being selected. So may I know what's going to be the result over here? Here we had been talking just about their selection, nowhere the ordering had come into the picture. Out of 6 number of boy, the one boy is to be selected, and out of 4 number of girls, all 4 girls is to be selected. Just a minute, it's been 3 now. It's been 3. 3. 3. For or, definitely addition is going to take place. Out of 6 number of and 4C2, or 6C3 and 4C1, or 6C4 and 4C0, and you will be able to get this answer easily. Here, is that audible now? Is that audible? Yes, no? Yes. So what I'm saying, even we had also been dealing with English language completely. So the student who had been preparing from either of the branch for GATE 2023 and 24 can also avail our courses, paid courses in English language as well, which includes pen drive, where all of the data would be given in a form of pen drive without any internet connectivity. You can use it very well. Similarly in G drive, video on demand, it's been very same as a Netflix, or you can say Woot or Amazon Prime. Tablet course, where the physical device would be given along with all of the data. You just had to open that tablet and you can use according to your requirement. PGG course, you must have been aware of it. And at the same time, we had been focusing over the online test as well. I would request to each one of you, online test has been our premium most product. Personally, I had been looking after the each and individual papers. In each and individual papers, we had also got a video solution as well. Approximately 2000 number of questions we are going to give, and within that 2000 number of questions, what we had been doing, we had been giving the video solution of each and individual questions. So I would request to each one of you, if you don't want to go for the test series as well, no, still you can watch the videos of the good questions, and that is going to help you a lot for your final preparation. Yes. Okay, then we will meet tomorrow with the same agenda at the same time, and that had been 7:30. There we are going to presume the part of the permutation and combination problem which we had taken today. I would request to each one of you, try to join this Telegram. So in future, any kind of doubts or any kind of communication you want to establish with me, you can have that. Just a minute. This one. Where it is been. Yes. Yes, this one. t.me/abcd123df. Yes. Surendra, I will try my level best. Definitely few number of sessions I am going to take on our this English channel as well, based on the concept of EMFT, which is been exclusively designed for the electrical and instrumentation side. That's been electrostats and magnetostats. Definitely I'll try to cover that part as well. So this is all for the today's class. We'll meet tomorrow precisely at 7:30. Be there exactly at 7:30. Bye bye. Take care.